So I have another interesting question, and this question is from waves. I think if you manage to watch the video on tutorial sheet, that should be three or two, but it should be three. Yes, three question. I don't know if it's question three. Tutorial sheet three, question three for physics. It's just basically the same concept here. So the question is, a circus performer stretches a tightrope between two towers. He strike one end of the rope and sent a wave along it toward the other tower. He notes that it takes a wave 0.800 seconds to reach the opposite tower, then 20 meters away. If a 0.00 meters length of the rope has a mass of 0.35 kg, find the tension in the tightrope. So basically here is just a simple principle which we have to apply. So here is a person, okay? Let's say that this person is standing, this is the tower, okay? So let's say here is another tower to the other side. So you strike, there are going to be a wave which is going to be generated, okay? Now we have been told that we're going to have the speed. Now when we're talking about the speed of the wave on a string, we are always talking about this, the tension force divided by mu, where mu is the linear density. It is given by the mass divided by the length. In this case we have the length, okay? The length of this rope is 1 meters and the mass is also there, so definitely we can clearly see that we have what, the speed of wave on a string, okay? Now our main interest here is we want to find the tension force, okay? So one thing, when you are trying to create a wave, okay, we are trying to create a wave, there is a formula which you have to know. The velocity is given by 2n times d divided by t. Let me explain now here. So n is basically the number of rounds, Sometimes if you are lucky, if they give you a question, they will specify, they will give you the number of rounds. But in this case, we have got for us to know that we have got one round. When you generate a wave has to come here and go back to that side. That is one round. In this case, we have been told that the wave only went to the other side. It didn't come back. So the number of rounds in this case is just half. So n in this case is going to be 1/2. That is half. Now these two, it just represent for us the distance, okay? For us to move from this point all the way to that point, it is the same distance, this one. Since we are saying that one round is from when you come there then you come back, that is one round. So even distance has to be doubled. That's why we have 2 here. So that's the meaning of 2nd. So this 2 is just basically for the distance. We are doubling the distance, because for us to have one round we need to go and come back. So that's why it's 2nd, where n in this case is the number of rounds. So in this case it just went to the other side, it didn't come back, meaning the number of rounds is just half, because for us to consider one round it has to go and come back. So it just went, it didn't come back. So n is equal to half. Now we want to find the tension force. So V, it can be replaced by the square root of F divided by mu. Let's first find the mu value. So mu is the mass is 0.350, the length is 1.00, therefore the mu is just 0.350 kg per meter. As simple as that. Now let's replace V with the square root of F. So I'll replace V with the square root of F over mu is equal to, I have 2nd divided by t. We have everything. Let's square both sides to get rid of the square root. Okay, allow me to put this just here, and I can get rid of this. So I'll end up having the tension force divided by mu to be equal to these ones. If I square them, it's going to be 2 squared is 4, n squared is n, d squared is d squared, t squared is going to be t squared. Meaning I can cross multiply. The tension force will be equal to mu times that is the same as I'll have 4 n squared d squared times mu divided by t squared. Let's try to plug in the values. This t is squared. Okay, t is now down. So the tension force will be equal to 4. The n now. N is the number of rounds. We say it is half, but we have to square it. D is 20, but we have to square it. Mu value is 0.350, but we don't have to square it. The time is 0.800, but we have to square it. So let's see the tension we're going to have. So our Ft will be equal to, now if I say 1 over 2, now I square it, it's 1 over 4. 1 over 4 times 4 is 1. So it's going to be 1 times 20 squared times 0. Times 0.3, I'm going to say 20 squared. Okay, 20 squared times 0.35. Okay, 0. So I'm getting, I'll say that is going to give me 1, because 4 times 1 over 4 is 1. Then 20 squared times 0.350, that is 140. Now this 140 divided by 0.800, now we square it. So the answer I'm getting is 218.75 newtons. So that's the answer for this question.